our introduction to the structured query language, SQL. Let's get our feet wet with one of the most important languages, if not the most important language, in database land. Here's what we will be working through in this module. We will talk about the history of SQL, its 4 subtypes, and find out why it is the standard data query language even today. Then we will jump straight into writing SQL statements in order to ensure that we can retrieve data from our databases. I'm going to use the movie stream database as my example in this video. So let's get started. SQL stands for Structured Query Language. There are 4 different types of SQL. Data Query Language, or DQL, is the one you'll use in order to retrieve the data from your tables. It focuses on all the permutations of the select command. Data Manipulation Language, that is DML, focuses on how to add, change, or delete data from the database. The commands we use are insert, update, and delete. We use Data Definition Language, or DDL, to change the database architecture. For that, we use create, alter, and drop. These commands change the structure of tables. Lastly, there is Data Control Language, which we use to set permissions for users. The commands to use here are grant and revoke. So why, despite all the efforts in the past few years to use advanced search engines for relational and non-relational database queries, has SQL not gone away? Here is why. Number 1, SQL is efficient, intuitive, and logical, and more than that, it has been around since the 1970s and is very well described in a number of international standards. This means that if you learn SQL once, you should be able to use it in all relational database systems. While many smaller companies experimented with SQL, the winners from the first database wars were clearly the software giants Oracle, IBM, and Microsoft, whose SQL Server originated from a Sybase architecture. Not necessarily because of their ingenuity, but because of their financial clout. Despite the challenge through more object-oriented, also called object-relational systems, such as Postgre, the need to contain and manage big data outstripped all other considerations. We're seeing this starting in the 1990s. With Teradata, the first SQL-driven data warehouse application, IBM DB2's Parallel Edition, which was designed for big data processing, and Sybase's IQ, which took on early analytics. But after working with the existing systems became increasingly frustrating, new architectures and ideas entered the scene, such as Hadoop as a data management system, MapReduce as a data sorting and aggregation algorithm, and of course the big 3 NoSQL systems, CouchDB, MongoDB, and HBase. But what do things look like these days? Well, here's a very recent ranking published at dbenginesranking.com. And as you can see, nothing much has changed. Oracle and MySQL, now also an Oracle product, still lead the pack, with Microsoft SQL Server, which is often used in the banking and healthcare industries, following in 3rd place. Postgre is only 1 spot behind, and the only newcomer to the bunch really is MongoDB, followed by the erstwhile big number 3 IBM DB2. Go ahead and pause this video and check out this URL here to see if anything has changed since the making of this video. Are you ready to step into the data query language? Well, here we go. To access our database after logging into the MySQL command line client, we type use and the database name and a semicolon. The semicolon is the command delimiter, which tells our MySQL engine that the command is ready to execute. MySQL will respond with database changed. To see all the tables in the database, we can then type show tables, which will result in seeing all the tables. Once you have decided which table to look at, you can type DESC and then the table name. This will show you the table structure the way it was installed. Here we're drilling down to the customer account table in the MovieStream database. Here we are, right in the middle of our MovieStream database. We use select star from customer account to see all the values in all the columns in the customer account table. That takes up quite a bit of real estate, so if we need fewer data, let's select fewer data. I can specify just the names of the columns I want to see, so if I want to know only which account IDs have made deposits, let's look at just these two columns. I type select customer account ID, customer deposit amount from customer account. And then I see just these two. But then, didn't we want to see just the rows that show the actual customer deposit amounts? So let's use a filter. We use the keyword where and then the mathematical expression of the filter to constrain our search results. And here we go. Just the 3 rows we were looking for. So the select statement really consists of 3 parts: the columns that we're selecting, the tables or views from which we are selecting them, and the where filter with which we constrain the output rows based on whatever criterion we specify. Here's another example. Let's say we want to look at our person table. It's always a good idea to know what columns are in it, so we look at the architecture with DESC. If we now want to know in which cities and states our persons reside, we select just these columns from the table. Now let's assume that we want to find just the cities and zip codes in California within that group. So we filter by that state. But now all the cities are out of order. What if we wanted to see them in the order of their zip codes? For that purpose, we tack the order by clause on, in which we use order by to sort by the values in the column that we specify. Here, that is person, address, postal code. The where clause, which we've seen earlier, is an awesome way of constraining your outputs. You have the option of using it with an equal sign for comparison. You can filter by a string as long as you enclose the string with single quotes. You can use it with more than or less than or equal to or more, as well as equal to or less. You can even constrain both sides of a search easily by using between. This will work with both strings and quotes and numbers without quotes. Lastly, you can use it with a partial string search using the like operator and the partial strings you want to search. This is where you need a % sign as the string wildcard. This is different than the asterisk, which is the wildcard for the command line. The % sign that we're seeing here is for partial strings. Finally, you can always connect the filters on the where clauses with or with and. Now, please stop the video here and try these options out on a table of your choice from the MovieStream database. We could not build MySQL queries to retrieve data if we didn't have the structures that hold the data in the first place. That's why DDL, Data Definition Language, is so important. Data definition language is actually not about data. It is about the database and its architecture. Data definition language comes in 3 commands. Create, which creates a new database object. That can be a table, a view, a piece of code in terms of a stored procedure or a function, that kind of thing. Drop removes any of the objects that you built with the create command. And alter changes any of these structures. For example, you use alter to add a column to a table, change the filter, that is the where statement, on a view, that kind of thing. As you can see here, we have to create a table first before we can insert data into it. To create a table from scratch, we want to get rid of any prior copies. That's why we start any create with a cleanup first. It is good practice to drop a table if it exists. That's why we do this test here. We then create the table with the create table command, an open and close paren and a semicolon. Inside the parentheses, we see the description for each column in the table. That is the name of the attribute, its data type, here int, its field length, here 11, and any constraints, here the fact that the customer account ID cannot be an empty field, that is a null field. Our table creation typically concludes with setting the primary key for that table. And now that we have built our table, we can insert data into it, right? Not so fast. Before you drive your car into the garage, shouldn't you check that you're the only person in your driveway? That's why we lock the table first to make sure we're the only ones writing into it. And then we insert data in exactly the same sequence in which we built the columns. Once we're done, we unlock the table again. That's how we create and populate tables. Another really important command in the DDL portion of SQL is alter. Alter means that we change the structure of an object. Here, we are adding a column onto the person table with alter table, and then the table name, person. Then we specify how we're going to alter the table. Here, that is by adding a column. This column is called premium plan. We describe the new column in the same way in which we describe any other column in a create statement, with the name of the column, the data type and length, and any constraints. Here that the column is empty by default. Here is what this looks like on the screen. And here is what this column looks like as part of the table. While data definition language builds and modifies the structures that hold our data, data manipulation language fills them up or modifies the data that already exists in them. The insert command, which we have already seen, was our first command in the data manipulation language section. The most heavily used one, though, is arguably the update command. The update command works like this. We update the table name and then use set and what we want to change in the attribute. If we left things right there and ended this command here with a semicolon, however, we would set all the death dates to January 1, 2015. Since it is very unlikely that all of our customers pass away on the same day, how about we insert the death date only for the one customer account that really needs to be updated? That's where we use the where clause. Our response from MySQL tells us that one row was affected, exactly what we wanted, and that one change was made, also exactly what we wanted. Now, we can verify that the death date was really changed, and voila, we did it. The update command is very similar to the select command in that it is most effective with the where clause. The last command in the DML series is the delete command. Note that the delete command does not need any column references because it applies to the entire row. Delete rows, not individual data points. If you want to delete individual data points, you will need to use the update command and set a field to null. So remember, delete is for rows and update is for data fields. This is why if we wanted to delete a row from here, the language table, the command may look a little incomplete. It is delete, and we're going to delete a row from the table in question, and we're going to specify the exact row. that we want to delete. And remember, with both update and delete, whenever you get to use where to set a constraint, you get to use all of these permutations. So let's look at what we've talked about in this module. We have discussed the history of SQL and seen that relational SQL-driven databases are still at the top of the usage chain. We then dove right into the select statement, followed by create, drop, and alter, all data definition language to change table structures, and then we used insert, update, and delete to manipulate the data inside those tables. Nice work! I look forward to seeing you again in a future module.